15 minutes for your presentation. 15, 1-5. Please remain within your time limit. And also for our friends from Sudan, you're all having 15 minutes for your presentation.
I will talk about soil characteristics and irrigation with a special reference to Zimbabwe. Like I've already said, my name is Emelda Berjera. I'm a freelancer consultant on irrigation and rural development. Zimbabwe, I'm sure most of you know quite a lot about Zimbabwe, especially with what is currently going on. But it is a landlocked country of about 390,000, basically based on the taxonomic levels, the order, the group, the family, and the series. At order level, we are only talking about the broader general characteristics of the soil. And we have got 4 orders. I'll briefly show you the characteristics and the description of the 4 orders. And at group level, we are getting into the details relating to the morphological, chemical, and mineralogical properties of the soils. Provide a natural way of recycling material and also protect the soil from erosion. They are very low in nutrient content, and they are highly permeable, and they've got a very low water holding capacity. But we find that in those areas we have got some smallholder farmers, and they certainly do some agricultural production of sorghum, watermelons, millet, pumpkins. Dimorphic, where we have the vertisols, we've got 2 groups there. These are soils with very active soil, and we refer to them as the black cotton soils because of the common use that they are used for. Very high in protein, and have got a very high nutritive value for wildlife and cattle. Therefore, ranching and wildlife is an important activity. The grasses that grow in this type of soils are highly palatable, and they are actually called the sweet veld. The third order, in the good times, that's where we were having even the 10-ton club farmers growing rain-fed maize within those areas. We also have the parapheralitic, which have got the innate clay. They are low in fertility. The sodic soils with very high exchangeable sodium and a reduced hydraulic conductivity. They are impenetrable to roots and even to water. They are very difficult to do any meaningful agricultural activity. But we tend to the soil classification. We also have what we call land classes. I'm not going to dwell a lot on this, but we have got land capability classes, and basically these classes are based on the limitations or the hazards that we might have in terms of agricultural production. And they are numbered from 1 to 8, 1 being those with the lowest limitations or hazards. Movement about text. The structure, which is basically rate, and this is very important for the crop tolerance. There are some crops which cannot tolerate high soluble salt content, the exchangeable sodium, the soil reaction, the pH, and these are basically very important besides, of course, for the selection of the technology or the method in terms of how we are going to manage and how we are going to feed the soils even under irrigation, the soil fertility, of course. Normally, the steeper the land or the proposed irrigation site, then the lower the irrigability class. I'll just show you the example that we have in terms of irrigation class. We have what we call the Class A, and these are the best soils or the best sites for irrigation, and we can do irrigation without or with very minimum precautions. And normally we tend to have slopes of less than 2%. We also have a Class B, where we can do irrigation but with a bit of some precautions or practices. And we need to have a good water management and also maximum efficiency of water. And the risks normally is about the soil and topography limitations in terms of maybe the depth and the slope, the suitability in terms of the type of the crops and the practices because of the soil and topography limitations. There are some soils or some areas where we are doing irrigation, for example, the veti soils in the low veld, where we are even having sugar cane, and also cotton and wheat with very low fertility. So you find that we recommend some irrigation, but the soil management and the fertility management has to be on the high side, and normally we tend to have low pH. And then the last class is D, and this class is normally not suitable for irrigation. So normally what happens is we determine this irrigability length classes during a soil survey specifically for irrigation, and that is done by the Department of Soil. I'm going to waterlogging, especially with the smallholder farmers, because in Zimbabwe we have got two different types of irrigation. We have got the parastatal and the privately owned land, where they are highly mechanized and also organized. And then we have got the irrigation for the smallholder farmers. These are the farmers, the peasant farmers, some countries call them. They tend to apply too much water, especially where we have gravity-fed systems. The water is just flowing, and as it is flowing, they also love to see water just flowing in the fields. And in some cases, we do not have inadequate drainage, maybe because we did not construct the drainage structures, or because of poor maintenance. The drainage structures are blocked or they are overweeded, and at times also seepage from canals. We tend to have erosion, especially where we have irrigation on steep areas. Technology challenges with regard to irrigation. How many minutes? Our costs, we tend to compromise on the selection of the suitable technology, so much that at times, although we might know that surface irrigation, for example, is not suitable for very sand soils, but because of the high cost involved, at times we tend to go for that, and we tend to have all these problems of leaching and erosion. Also, technology operation and maintenance, a high cost, especially for pressurized systems. The example that I wanted to talk was about a salinity problem on a sugar estate in the low veld, and they found out that the salinity that came on this estate because of the rising water table had an adverse effect on plant growth and the yield of the sugar cane, and also even on the soil fertility, specifically on soil microbial biomass. And another example in the southwest, where we lost 20% of the area because the farmers, it is a gravity-fed scheme, farmers were applying too much water, the water table rose up, and the area is now waterlogged. We can't get in unless, of course, we get in to do some mitigation and remedial measures. And some families actually had to relocate those who were very close to the schemes because the houses either collapsed or they were not inhabitable. The parameters that I've already highlighted is the parameters for irrigation are very important for planning and designing. But like I've already said, we normally tend to determine those parameters and those irrigability classes as and when we want to develop an irrigation scheme. It's not information that is readily available for the whole country. And at times it's very difficult to get the people from the Department of Soils to come and do the soil surveys for our irrigation schemes. And most of the times they don't even have the budget for that. And also, besides for planning and designing, these parameters are important with regard to irrigation water management. If we do not do proper irrigation water management, these soil parameters tend to change and we get problems. And I've also realized that there is also variation in the region, especially the southern part of Africa, on how this data is packaged for irrigation development and management. Thank you.